Well, hello and welcome to AWS Made Easy, episode number 11. I'm Stephen Barr, joined by me and co-host Rahul Subramaniam.
Hey everyone, welcome back. I can't believe we are at episode number 11. Last week was pretty awesome. We did the 10th episode, and it feels awesome to have this consistency.
Yeah, really enjoying it and enjoying the process. I still can't believe that we can do. We don't have a production crew in the background. It's you and I, and a bit of help from a designer to help with some of the clips. I still remember that part in Back to the Future 1 where the 1955 Dr. Brown is looking at the video camera and going, a portable television studio. But I think this is almost the extension of that, where now we have a whole live TV studio, and we can make things with pretty good production value, I think.
I know. I mean, and if it weren't for the cloud, I don't even know how this would be possible.
Oh gosh!
Just thinking about this a few years ago, yeah, just impossible.
And all the little details, and we're using a really neat thing called StreamYard, and to manage the multiple destinations, because hopefully we've got people on Twitch, on LinkedIn, we're doing Facebook Live now, and Twitter live streaming, and getting all the bandwidth and the distribution, and handling all the sessions and the tokens, and even some of the things behind the scenes, like getting the audio levels right, that it works out automatically. It's pretty neat that we can do it.
No, yeah, I think this is quite revolutionary. And given how many people are now independent podcasters and YouTube broadcasters and so on, I think I think platforms like these are incredible. And I think we should one day, invite someone from StreamYard to come in and talk about how they've created this service and what goes behind the scenes of something like StreamYard. I think that'd be a very interesting episode to have.
Yeah, I'm gonna put that down on my notes. I will reach out. StreamYard.
Yep.
That would be a lot of fun.
Which also reminds me, I think we need to also get on YouTube. I just realized we're not streaming to YouTube. So next week, let's see if we can get there as well.
Yeah, all right. I'll add that to the destination list. It's really neat. Yeah, I can do that.
And it makes it so easy, right? I mean, you just decide on all the destinations that you want to be in and just configure those. Fairly straightforward.
All right. So we'll see you next week on 5 platforms. That's Facebook, LinkedIn, Twitch, Twitter, and YouTube.
Absolutely. So how was your weekend, Stephen?
Really good. We had some family come in from out of town, so a lot of eating, a lot of tourism, and it was really nice to catch up with people I hadn't seen since before COVID. And everyone's growing.
Did you just have the wedding in your family, or is it yet to happen?
No, that happened.
Oh, that happened? Awesome.
Yeah, so that was a big.
Did you manage to fit everyone in the portico? Which is
it worked out. It's surprisingly well. In one of those things where it's hard to see it in advance, but then it actually worked out really well. So, and
Seattle weather held up.
We were actually really lucky that it was just a little bit overcast, because I was worried that if we're going to have one of those really nice hot days, you get those classic fail videos where someone passes out during the wedding party. So luckily, it was a little bit overcast, so I think the photographers were happy, and it was nice and cool. So I think it was just perfect.
Oh, that's awesome.
And then it rained the next day, so threaded the needle on that one. What about you? How was your weekend?
Weekend was good. I celebrated my birthday.
Oh, happy birthday.
Yeah, thank you so much. Give me this 1 second. And so I celebrated my birthday. Had lots of family around. So that was pretty awesome. And just a quiet weekend with the family. Nothing earth-shattering. And I spent a little time practicing my new acquisition, which is a ukulele that I picked up from Hawaii.
Let's hear it. This is live.
I don't know if it's tuned. I'm still learning the chords. So someday when we don't have an AWS announcement, which seems very unlikely, I might actually play a song.
Well, actually, could you do like some intro music? That'd be kind of cool.
Try that. Let's
Yeah,
try
we'll
that.
mix it in. I mean, it's hard to find good royalty-free music, so if you get some good intro music and we'll mix it in, I think that would be fun. Or for some of the transition music.
Yep, we can definitely give it a shot. Would be an interesting experiment. So yeah, one of my hobbies is I collect musical instruments from wherever I travel, something that's unique to the location, and try to learn how to play it. So yeah, it's fun. And
We're
yeah,
excited to have a ukulele-based intro and outro coming up soon.
let's add that to our list for the show. Okay, so we have a ton of announcements that, as usual, came up this week. Shall we dive right into it?
Yeah. Oh, well, last little announcement is, I'll share the screen. You might be able to meet us in person in August. We'll be in Anaheim, not Disney World, or Disneyland. Yeah, not Disney World, but the AWS Summit. But maybe we'll go on a roller coaster after. AWS Summit, Anaheim 2022. So if you happen to be there, it's August 18th. We might see you there.
Yep, and I'm really excited to say I'm going to be doing 2 talks at the Anaheim Summit. The first one is going to be about why you should think of code as liability and discuss the future of how apps should and could be built. And the second one is how you can systematically get to 70-80% of cost savings on your AWS bill. And what are the methodologies that we've tried and experimented with and refined over the last 14 years trying to get there. So we'll be sharing a lot of those insights. So would love for all of you to come and join us in Anaheim. And if no one shows up, I am bringing my ukulele along. So
all right, so you will find us either in the convention center or outside.
Correct.
It's fun. I love that code is a liability. I don't want to give it away, but it's almost like that word serverless, right? Where you think code, that's my asset, that's my IP, and then serverless. Where's my computer? But that's such a great. Anyway, I won't give it away, but that's an exciting talk that's coming up.
Yeah, and would love for an awesome discussion at the end of it. So yeah, please come and join us at Anaheim, and looking forward to it.
All right, well, let's cue our transition, and then we will be talking about EBS Elastic Volumes. So here we go. Okay, so the first announcement I want to talk about is Amazon EBS Elastic Volumes automated performance settings. So the big deal, and I think we've been talking about this particular change for a while, is it's saying when customers use Elastic Volumes change from GP2 to GP3, EBS will automatically provision the target GP3 volume with equivalent IOPS and throughput. So GP2 versus GP3, what's the big distinction here, and why would we want to do this?
So I think now coming up on a year and a half, AWS announced the new volume type called GP3, which basically has a minimum IOPS of 3,000. It's significantly more performant than GP2, and it is 20% cheaper. Like, that's the beauty of GP3. And what this announcement says is that every time you modify your volume, and if it is the Elastic volume type, so I forget what the cutoff date was, but beyond that date, all the EBS volumes that you launch, fresh, they are of the type Elastic volume. So it's very easy to change the Elastic volumes, volume types. But when you move those from GP2 to GP3, then there's a bunch of settings that get carried over. So for example, if you have your IOPS, no matter what your IOPS is, if it will set the IOPS to either the minimum of whatever the default for GP3 is, which is 3,000 IOPS, or it will set it to whatever IOPS you had on your GP2 volume automatically without you having to specify it explicitly. Okay. So it's actually pretty straightforward. My only grouse about this with AWS is that the default for launching an instance is still a GP2, and I don't understand why. Like, they go through so much lengths to try and save money for the customer, but they're literally missing the most obvious thing. If we can just share my screen.
Yeah, let's do that.
I actually want to show this up. I wanted to, kind of try something out over here. So it's the first time that I'm trying to screen share and try and do a live demo. Thankfully, it's an AWS system, so I don't have to worry about things going awfully wrong. But if you look at the default storage, it always shows up as GP2. And you have to click this, select GP3 by default if you wanted to. And I don't see any reason why it shouldn't be GP3 by default. If somebody wanted something more specific, yeah, go choose something specific. But I still don't understand why AWS has left this one to be GP2 by default and not GP3. Now, let's just go ahead and launch this instance. Hopefully.
Well, I guess it's to give us something to talk about why we need to make it easy.
No, absolutely. I mean, it is 20% savings that is left on the table, specifically for every single instance you launch. Like, imagine the friction that exists because you have to scroll down that huge list of configuration parameters and then choose something that's not the default, right? That just makes no sense at all. So let's go to this particular volume.
Okay.
Let's pick up our storage. And here's our volume. If we go to this particular volume, you can now say modify. And because this is an elastic volume type, you can choose to make it GP3. And if you look at it, the IOPS and the throughput got automatically populated. Okay. Here, because the default, I think on GP2, the default IOPS is about 100 IOPS. So it defaulted to 3000 IOPS. So you get way more performance by default on the GP3 at 20% the price. So, I mean, there couldn't be a more of a no-brainer answer here than to start with a default of GP3 and just, if you're using anything less than 3000 IOPS, just switch over to GP3. I don't even know how much easier that, or how much more straightforward that could be, but they just don't make it that simple. They complicated with this. So for those of you, this particular announcement basically says that if you decide to modify your volume, so start with the GP2 default, and then when you go to modify your volumes, as long as it's elastic volume, they've basically crossed that cutoff. Then these two parameters, the IOPS and the throughput, are automatically going to be set to whatever the defaults in GP2 were, or the minimum of what GP3 supports, which is significantly greater than what GP2 supports. So that's it. I think it brings up CloudFix.
So it's pretty neat to see the ability to do it with a click through the console. But what if you have hundreds of volumes? You're not going to do that. Is there a way we can automate this?
Absolutely. I think that's where CloudFix comes into play. I mean, you could write a very simple script that goes through all your volumes and constantly scans it. There's just a lot of operational overhead in trying to do that. But we've got a tool called CloudFix that does pretty much exactly the same thing. It scans through all of your volumes that are GP2. Any GP2 volume that is using less than 3000 IOPS, it'll convert it to GP3. And this brings up a really neat solution where now if you have a GP2 volume with more IOPS, we have to look at some of the end use cases, but we might be able to move those also by default, carrying over all the performance parameters because that's taken care of by AWS automatically for us. So it actually opens up a lot more volumes in CloudFix for us to then automatically fix. So
okay, so you're actually, as you're doing the transition, you're looking at the usage and then setting the settings on the new volume type. So it's literally as good or better than the previous one while still giving you a savings.
Exactly. So yeah, check out CloudFix. If you have loads of volumes, I am pretty sure you're going to be exhausted clicking through every single volume. You just saw the exercise that I had to go through. You have to click on the, actually, should we go over that again?
Yep. No, I think we'll put that in the highlight reel of what to do, what not to do. If you just do it once or twice, but not 100 or 1,000.
But not 100. Yeah, it's just too painful to go through every single volume, then click on modify, then go into the settings, change it to GP3. It from the drop down. Yeah, you just don't want to do that. You want something that constantly sweeps your accounts, looking for these kind of volumes, and fixes them automatically. Just takes care of that for you.
Perfect. Yeah, and then I guess these types of fixes you want to. It's easy to forget to do them. Like I know I still have a few S3 buckets that really should be in Glacier. I haven't accessed them in a long time, and there's not much in them. But again, it's easy to forget, and it's still money on the table.
Correct.
So I'll have to get those done. Let's run CloudFix on my account. All right. Awesome. Well, anything else to say about EBS Elastic Volumes?
No, just AWS, please default to GP3. Like they just built an entire new console with a new UX, all of that stuff. Like, do the simplest stuff first. Just default an instance launch to GP3. You'll save people tons of money. You'll make customers very, very happy. So please do that.
All right, I'm going to post that particular plea as a highlight, so we can say, all right, please do this, save some money. All right, well, let's transition over to Redshift Serverless.
Awesome.
Okay, so the next announcement we're going to talk about, and I'll put this in the comments, so you can follow along for the link. And even this part, like we talked about with StreamYard, I'm putting it in one chat window, and it's putting it out into the chats of Facebook and Twitch and Twitter. That's pretty neat. That's a lot of API integration to not have to worry about. So Amazon Redshift Serverless, now generally available. So Redshift Serverless, that's the idea of Redshift. You've got this big data warehouse. And no, I personally don't have any data needs that are big enough to use Redshift, but I wanted to use it. But I don't want to have it just have a Redshift cluster sitting there to analyze my couple of gigabytes of data. That seems like overkill. But now Redshift Serverless, I can have some things in an S3 bucket or an Aurora Serverless that then get pulled into Redshift Serverless.
Correct. Yeah, so I think serverless is the trend. I think they figured out the serverless pattern really well with the Aurora team. And Aurora went through 2 revisions of serverless, the V1 and then now V2. And I believe that this version of Redshift Serverless is built pretty much like the V2 version, where you only pay for whatever compute and time that you're using those instances. A big deterrent for Redshift really is the cost, right? I mean, you don't really run your analytics workloads that frequently. And when you actually do want that, if you were to keep those D-class instances or D-family instances running for a really long time, it can cost you a bomb. So instead of running those instances all the time, the fact that now it can scale up and down as needed, and you pay only for compute when stuff is actually getting used, is pretty remarkable. I would add this. I like the variety as well within the AWS ecosystem, in that if for analytics workloads, you don't care so much about near real-time latencies, then S3 with Athena is a really good option. But if you really wanted, near real-time results in your dashboards and stuff like that, then yeah, Redshift is really valuable, but costs are significantly greater. And so this just makes it more economical to use Redshift.
And this is what it's saying is on a per second basis, right? So it's not rounding to the nearest hour or half hour, but per second. That's pretty phenomenal that they can do the billing down to that fine grain. So you really wouldn't hesitate to use this. Well, you can monitor your plant irrigation system with Redshift if you really wanted to now. You wouldn't have even considered doing that before, but you could.
Yeah, I think I generally use this phrase that when something is basically a cannon to swat a fly, This is one of those scenarios where, for a home IoT system to use something like Redshift, would literally be that analogy where you bring out a cannon to swat a fly. So considered and rejected.
Fair enough. I do like this simplicity here of no need to choose node types, workload management, scaling, all that stuff. It really feels like it's another level of abstraction above, once you start going through the menu of regular Redshifts, there's just a lot to think about, and it's a lot of decisions you have to make up front. Whereas this, you're not. You're just scaling as you need.
Exactly. So I think this is pretty neat in terms of enabling people to use those analytics tools really quickly and get started. There are the fact that they're actually taking away a bunch of decisions makes it simpler and easier for people to adopt these services. Unlike another announcement that we're going to be talking about in just a bit, which does exactly the opposite. So mixed signals from AWS, but we'll talk about that. We'll come to that in just a bit. But this is definitely simpler. I love the simplicity aspect of it, and the more choices that AWS takes away and just gives you stuff by default where they take care of stuff behind the scenes, the better it is for customers, in my view.
And one thing I really like about Redshift as well, that in terms of adding in practical features for customers, that they even have preloaded data sets of kind of background data that you would like say if you had sales data by county or by postcode, they have preloaded data that maybe you can want to get population data by those same things. So then look at some metrics. You don't have to go hunt that down from the Bureau of Labor Statistics or wherever that happens to be, and then clean it and parse it. That's already done. So it's exciting that there's data for you to be able to do that kind of thing. Because that can be really difficult when someone's just getting started, is just finding some sample data. If you just want to explore it. So I like that there's sample data available for experimentation.
Exactly. No, I mean, all of those things help a ton. They really do help a ton to get started. There are actually a bunch of patterns that you can get started with right out of the box. There are some CDK, templates and CloudFormation templates that get you set up with a basic Redshift Athena QuickSight kind of setup, so you can kick stuff get started with stuff right out of the box. So I would encourage folks to go try that out, and then you can load other data sets in it to get your analytics workload going. So
great.
Good one. Or I'd say thumbs up on this one, AWS. Simplicity and serverless, definitely the way to go.
Yeah, absolutely. I was just thinking about, I want to have a little OBS overlay that we can give a score to each announcement and just push a button. I'll give this a 9 out of 10 or 4 stars or 5 stars, whatever it is.
Yeah.
All right, I like this. Thumbs up, Redshift Serverless. That's very exciting. Any other announcements before we move on to Timestream?
I think there were a couple more announcements. Redshift announced support for the R6i, if I'm not mistaken.
Yep.
And row-level security.
Where's the R6i?
Oh, sorry, no. R6i was on Postgres, if I'm not mistaken.
Yeah, there's row-level security. I'll put that in the chat.
Yes. So this one basically just gives you more control about what you expose. Now, typically in a data warehouse, you've got, data from all over the place, and you want to restrict at times what data gets exposed by a query. You don't want all the data across all the joins, because effectively what you have in Redshift is flattening out or denormalizing a whole lot of data across, different sources, and then dumping it all in one massive columnar store. So you really don't want to expose everything to everybody. So now you get row level control to make sure that you're exposing only what is relevant.
And especially, for example, I used to work in healthcare IT, and not everyone should have access to some of the billing things, whereas not everyone should have access to, say, diagnostics or medical code and vice versa. And so being able to have these
Right.
policies that can, like you said, without having to make some really complicated schema or something like that, you have column and then row level access control.
Correct. So this one is neat. And
And what was it?
I think there was one more Redshift announcement.
It was the
which
cluster resize.
All right. So again, if you did not want to go with serverless, then
Here we go.
cluster resize performance carries over. Pretty much the same way. So, sorry,
Oh, some of the
cluster
benefits.
resize used to take forever to run because they had to kind of replicate a whole lot of stuff and make it all work. Now that performance has been improved pretty significantly.
I mean, it seems like a lot of the performance that we're seeing are really functions of performance to Nitro and to how quickly data can be moved around, like behind the scenes.
Yeah. And the other thing that I really wonder is if a lot of these instances are actually now using Graviton, where they have possibly tuned a bunch of the operational pipelines for Redshift and some of the more cloud native services. So that'll be an interesting one to find out whether they're using Redshift to do these.
Yeah, no, I would love to know the behind the scenes Graviton underpinning. So we'll try and see if we can find someone to talk about the behind the scenes of some of this Redshift cluster resizing and other similar things. See how they're doing that. If they're willing to talk about some of the details. I know some of it's a bit say classified, but sensitive.
Yep.
But it's still be interesting to know.
Absolutely. Now, we should probably have someone from the Graviton team come in and talk about this. So
yeah. All right.
Yeah. Okay. So yeah, I think those were the announcements on the Redshift one.
Nate, well, let's take a quick 30-second break, and then we will switch gears over to Timestream.
Sounds great.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, we are back. Amazon Timestream announces improved cost effectiveness with updates to metadata metering. So I have to transparent. I haven't used Timestream too much. It's the time series database, and the idea is okay. With this, let's just parse this together. No longer charge customers for the dimension names and measure names associated with ingesting, storing, and querying data written after July 8th, 2022. All right.
Yeah. So Timestream is neat. And so for those of you, a time series database is basically a purpose-built database for data that basically has your date time as your primary key or as an index, and that allows you to kind of partition your data by time, right?
So I guess one very interesting one at the moment: exchange rate data. That's time series.
Correct. Or stock prices. That's another time series, data.
Or Bitcoin prices.
Logs, event logs. So let's say you have a system that's just generating a ton of events. All of those event logs, network traffic monitoring, like your VPC logs and stuff like that, that's time series data as well. And Timestream actually provides a very simple interface to take all of that data, load it up. It stores it up internally very sequentially. That way it's easy to index, easy to retrieve. And then you can actually perform time-related operations. So if you wanted aggregations over a day, over a week, over a year, things like that, it becomes easier to do with a time series database than trying to take a conventional relational data store and try to do the same thing with that. Yeah.
And
Go ahead,
this
Stephen.
stuff is really, it's again with a lot of technology, it seems okay. It's just sorted by one column. This stuff gets really tricky to deal with in practice. Yeah, I used to do some graduate level time series analysis. We did these auto-regressive models and integrated moving average. They called the ARIMA. That was auto-regressive integrated moving average, where you'd want to predict something and you'd have the moving average of, say, the past hour or the past day or the past month, and the different weights on different pieces of time. You have to adjust for seasonality because, like, say, sales is often very seasonal. So you want to adjust for is it well, here it's the holidays or now Prime Day. All those things you want to adjust for. And it just gets tricky to do in practice. So having a purpose-built data structure that can scale and handle this at again any scale you want, trillions per day, that's really exciting to deal with.
Yeah, absolutely. And the only confusion for me, and again, I'm not coming yet to the pricing part of it, but the part that I don't get in terms of AWS's vision, and something I brought up a few times, but again, because AWS has different teams, they take completely different paths. CloudWatch is itself a time stream data store, if you really think about it.
Mm-hmm.
You can basically keep, reporting events into CloudWatch, and you have all the aggregations with metrics. And then you also have dashboards that come right out of the box for you. And then you can have alarms and alerts on that time stream data. So CloudWatch actually seems like a pretty good encapsulation over something like time stream, which gives you all these other benefits. But if you literally needed to use all that raw data and write your own queries and manage your own metrics and aggregations and all of that stuff, then maybe you wanted to use time stream. But I haven't come across a scenario where I would pick time stream over CloudWatch by default yet, but I would love to hear from the audience if there are scenarios where you believe that you pick time stream over CloudWatch. I'd love to hear.
Okay.
I know CloudWatch is meant for logging fundamentally, but logging is just another way of thinking about, logging is almost synonymous with taking a bunch of events and putting and ordering them along the axis of time.
That's a good way of thinking, right? What is the real fundamental difference between log analytics and any other type of time series analytics? I think it might be, you basically want to ask the same questions, like what happened in the past, what are the patterns, what are the anomalies, what are cyclical variations, and what's going to happen in the future.
Correct. I think in fact, something like logs needs additional features like full text search on them. But net, I feel like something like something like CloudWatch would actually be more popular than TimeStream for that very reason. You get all of that stuff out of the box as a service. And so I'm still confused about who uses TimeStream as their time series data store as against CloudWatch and why they made that decision.
That is a really interesting point. Well, to users of TimeStream or TimeStream developer advocates, let's love to know some use cases, and yeah, please reach out. We'd love to. And I'll start looking on Twitter to see where TimeStream is mentioned.
Yeah,
neat. All right.
So
let's see. Well, this is
coming back to this cost announcement over here. Just getting to the point of the announcement.
Yeah, good point.
Yeah. So AWS had a crazy multi-dimensional costing matrix that, I always used to be so confused by it every time I looked at it. Thankfully, no one ever used it, at least within our org. So we never had to go through the details of how we priced it and how we planned for it. But yeah, it was insanely complex. Now, hopefully, with some of this stuff being simplified, people might actually start to not get confused by just the pricing and the documentation, just start using it more often. So
I guess that's one of the things we heard. What was it? It was the DynamoDB team where they said at one point they had pricing that was a little bit confusing, and they've they've had to simplify that. So it is a pattern amongst different users of different AWS services of simplify pricing.
Yeah.
Because although the team that develops it has a model of all the different dimensions and the constraints, ideally that should be somewhat opaque to the end user.
Yep. I just thought of something. From our next episode onwards, we should figure out if there's a way to have the stamp come in on these announcements where we say simplified, thumbs up.
Okay.
Like that kind of a stamp, and then there are announcements that make things more complex and make AWS customers make so many more choices that are hard. So yeah, we should I know we have an opinion about these, about what are being simplified and what instead are being made more complex. So yeah, let's share that with everyone.
All right. That sounds really fun.
This is certified as, this definitely simplifies the AWS world.
Yes. And it is a trade-off, right? Because as the services become more generic, or I guess as more use cases come up in practice and features get requested, that obviously the scope enlarges over time. That's the general trend. And so it's really difficult to simplify things and get that exact level of usability where almost every use case is covered, and yet it's still approachable for someone who's new to it without having to read a couple hundred pages of manuals or make an expensive mistake.
Yeah, I think that's where you kind of have two variants, right? I mean, something like Aurora, you have the serverless and the non-serverless version, but the serverless part of it addresses 80% of use cases.
Yeah.
And for those who are on the edge, you've got your levels of control as need be. But to take something that's complex and simplify it with serverless is great. Simplifying the pricing and costing mechanics, yeah, definitely helps. It definitely helps with adoption, without a doubt.
Yeah. It's funny. I was reading a very similar discussion. One of my favorite hobbyist languages is Haskell. And they're at this point where the compiler is somewhat straightforward to extend, but they've made so many syntax extensions and other additions to the base language over the years that now it's like, unless you're an expert and have been following it for the last couple of years, it's really hard to just jump in. And so there's been discussions about, well, should there be a simplified common Haskell variant, which takes some of the established, the middle of the bell curve patterns and says, okay, here's where you start. And there's all this stuff at the periphery that you probably don't need. And I think that's a good thing to do as things evolve, is to have highlight what's the common path.
I think it's the same thing with Lisp. I mean, you went with Haskell and functional programming. I went with Lisp because I'm an Emacs person. I hope there are no rotten tomatoes thrown at me. But yeah, I'm an Emacs guy. I've always been an Emacs user, and eLisp was the way to kind of live in that world. And Lisp went through its cycle of all kinds of different variants of Lisp. In fact, we had a product that we acquired, I think, in around 2005, 2006, which is basically a real-time process control engine written in a variant of Lisp that existed in 1970s. And the company that built the compiler for it was, again, a variant of Lisp. They went out of business somewhere in the 80s. And when we acquired the product, there wasn't a compiler. There wasn't a system that we could continue working on that process control engine. And it was really important because significant industries and big infrastructure organizations used and continue to use that platform. So we spent a ton of time translating and moving all of that stuff to Common Lisp. So unlike Haskell, they were able to actually create a variant of Lisp called Common Lisp.
Yeah.
And we were able to migrate all of that code base to that Common Lisp variant. So
Oh, we have to have a story hour where we hear kind of the details. That sounds pretty fascinating.
Yep. Now, we went through some harrowing times with that version of the product.
So I guess to summarize it all, we are in favor of simplicity, and yet still we like the extensibility, but we have to know, okay, it's good to be able to communicate that through the UI or through the documentation or both when you're in the common path and when you're not.
I'd go one step further. I'd say default on simplicity. And if you have additional bandwidth and you want to showcase something, then have that as an extra, but default always to the simple, easy, straightforward solution so that it's easy to adopt.
Cool. I like it. All right.
So, awesome.
Well,
Next one.
Okay. We are going to be talking about, let me load up the banner. We will be talking about Connect customer profiles. 1 second here. All right, Amazon Connect customer profiles. And this is saying it now enables you to integrate unified customer information into your custom agent application. So the idea of this is, say you're at a call center or in some other way you are interacting with customers, and as you're interacting with them, you want all the background information to come up. Is that the idea? And then you want to know, oh, and I see, leveraging machine learning-based entity resolution to create single unified profile for each of your customers. That's a big deal.
Yeah. So Connect has something called find matches. So what it does is fuzzy matches the idea of a profile. So let's say you had NetSuite, which is your financial system. You had Salesforce, which is your CRM. You have Zendesk, which is your support system, and let's say a few other systems that you use. Each one of those systems has a different concept of a customer, right?
Yeah.
You've got emails that might vary, the person might vary, the name of the customer or the company might vary. Like one place you might say IBM, in the other one you might say IBM Asia or IBM US or whatever, or you might call it IBM Corp. Even though you and I know that it's IBM, for a machine to know that just IBM and IBM Corp and IBM some other subsidiary might all refer to the same customer and the same person and the same team, that's hard for that kind of resolution to happen. So what find matches does is, Connect basically can act as your central manager of your customer profile, where you can bring in data from all of these different systems and create this amazing 360-degree view of your customer across all of these different systems, all of their interactions in support or with support, your interactions with your sales team, your, all the interactions that they've had on billing and finance and purchases and stuff like that. You can bring it all in one view. And that's what Connect does. It disambiguates the idea of a customer across all of these different systems where you pull in data from, and gives you that one view. What this announcement says is you can now take this profile and export it into whatever system you use for your agents. So let's say you were using, Twilio to contact your customers. Then you could, in your Twilio dashboard or your agent, you could bring in this customer profile information and leverage it. So I love Connect for two reasons. One is, if you just looked at the pace at which they've been bringing in some amazing insights into this platform, it's been crazy. I think out of the last, including this one, if you look at the last 11 episodes, I think we brought up Connect in maybe 7 of them. So the rate at which they're announcing new stuff coming to Connect just absolutely is mind-blowing. And they are turning into an amazing, amazing platform. So if you haven't checked out Connect yet, please do. It's really awesome. Super simple way to get your call center going. Create a unified 360-degree profile of your customer, integrating all of these other peripheral systems that you use. It's just awesome. And for me, the underlying find matches algorithm is just amazing. Like,
a couple of years ago, I wrote a master patient index for a healthcare provider, and it's a similar idea, right? They have, say, one doctor. So my name is Stephen, obviously, but sometimes people will write it down Steven. Sometimes people write it spelled my way, Stephen, and then sometimes they'll have a middle initial. Sometimes what's often happens in international situations, we still use month, day, year, but often it's day, month, year. I'm glad that I'm born after the 12th, so I don't make that mistake. But when I was living in Australia, it took me a really long time to get day, month, year. Is it November 10th or October 11th? It was really hard to, and those kind of swaps happen. And so having a machine learning system that can look for those type of things and say, okay, this is probably the same person.
Exactly.
Stephen spelled Even and Stephen Phen, but with the same birth date and the same social security number. Yeah, we're the same person.
Correct.
And that's how identity resolution works, is matching, a certain number of points that match create a higher threshold. That's a really big deal for data quality and keeping control over how many actual entities you actually have. And I really like this idea of the contact center agents. They have this being able to have a quick profile of the customer to, like I said, provide a more personalized service.
Exactly. And getting this right is incredibly hard. Like, we've made multiple attempts over the years. I mean, when the technology never existed, that tried to disambiguate. And more often than not, the data is just so dirty that doing it is incredibly hard. But the Connect team seems to be doing incredibly well in, getting all of that lined up and working. So kudos to the team. Kudos to the pace at which they are kind of releasing all of these new features. And I think on our simple versus not simple meter, this one is a hard one. I think I would still put it in the simpler category because they are taking away a whole bunch of stuff that is today very custom, tons of custom code that people are still writing, and moving it into a simple API call, or in fact, it's not even simple API call, I'd say. So by commoditizing a lot of this function, they're simplifying it. So I would give it the simplifies or simplified tab or stamp. But yeah, it'll be interesting to see as they increase these number of features, if they start exposing a lot of this to the customers and having them control a lot of these parameters, then I think they'd be going down the wrong direction. So I love where they are at right now. I love what they've done so far, but I really hope and pray that they don't go down the path of giving too much control to the customers and overcomplicating it in the process.
Yeah, that makes a lot of sense, because the number of dimensions and variables here could just explode, and then you can, Well, all right, we will have those banners and pop-ups for the next episode. I think it's going to be a lot of fun. All right,
we just need a big hand coming in with a stamp.
Yeah. Okay. All right, we're gonna have some fun with this. All right, well, let's take another 30-second break, and when we come back, we will be talking about Aurora Postgres.
Is your AWS bill going up? CloudFix makes AWS cost savings easy and helps you with your cloud hygiene. Think of CloudFix as the Norton Utilities for AWS. AWS recommends hundreds of new fixes each year to help you run more efficiently and save money, but it's difficult to track all these recommendations and tedious to implement them. Stay on top of AWS recommended savings opportunities and continuously save 25% off your AWS bill. Visit cloudfix.com for a free savings assessment.
All right, we're back with Amazon Aurora PostgreSQL Compatible Edition now supports R6i. The R6i Xeon Scalable processors. Let's see, these are huge. Well, the 32x large. That's 128 vCPUs and a terabyte of memory.
Yeah.
That's really impressive.
No, I think this announcement basically, the thing with databases is that you always want to have the biggest, largest instance. Okay. Especially when it comes to relational data stores. You want to load up as much in memory as you possibly can. Or let me clarify, you want the biggest, largest instance in terms of memory. And you want really fast IOPS because you want to load up as much data as you possibly can in memory so that your responses are super quick. And you want to be able to read from disk as quickly as possible to load it into memory, right? I think the CPU doesn't matter quite as much unless you abuse the database with stored procedures. Okay, so I would really advise do not use stored procedures with databases because it's the old school way of really messing up your databases and creating a Frankenstein monster for you in the long run. Where I've seen people do everything from ETL to business logic to all kinds of other operations with stored procs and mess up everything. But if you use it right, you should need tons. The ratio of CPU to memory should be really low.
Okay, so this is reminding me of a story time episode we'll have to do. I was a machine learning consultant, and I uncovered a machine learning model implemented as a mountain of 1,200 stored procedures. And no one knew how it worked. And like, why is this taking so long? And that was quite the story of unpacking this model. And of course, the person who wrote it was on their way out, and that was a fun experience. Yeah.
Okay, I think I win this one. The worst one I have seen is about 6,500 stored procs. And this was an acquisition that came out of bankruptcy. So there was no team left. And unraveling 6,500 stored procs across, I think, if I'm not mistaken, this was almost 400,000 lines of code.
Oh, wow.
Was an absolute nightmare. And this was an on-premise database that we were trying to bring to AWS. So I think I win that. I win that story type challenge.
One of my favorite sci-fi authors, Werner Vinge, he talks about, in 1,000 years, there's going to be the profession of a computational archaeologist who's going to have to dig through thousands and thousands and thousands of layers of things, just like we look at sediment build up in these rocks. And that's these stored procedures, calling stored procedures. Where's the actual table here?
I swear, and it's really hard to even navigate all of that code because it's all embedded and sitting inside your database, and logging is crap. The traceability is terrible. Going and unearthing stuff. Like, I think if I look back historically, right, the fact that we did not have much network bandwidth available, where pulling out data and doing something with it was expensive, made people do all kinds of stuff, just cram everything into the database and do it. That's kind of how they went about it. And that was the legacy way of doing it. So now that you have got all these powerful machines, I think people might still have a tendency to do a lot of that. But please, I urge you not to do that. You are just creating a monster to deal with at a later date. Keep the data stored just for data and put all your other ETL and business logic and all of that stuff elsewhere. AWS makes it really easy to use other services to do all of that really well. Use the database just to store data and retrieve it. CRUD operations, that's all. That's what you need to do there.
I agree 100%. Yeah. And even with this 32.x large, I think 6,000 stored procedures will still figure out a way to slow this down.
Absolutely. So I think here, like the more important thing is this gives you nearly a terabyte of memory, which is awesome, right? I mean, you want as much memory as you possibly can. I wish they gave a little more flexibility on choosing the ratio, but I understand they have to do those families and handle it that way. On my simplify versus complexify, if that's a word, I would give this a complexify stamp, because I shouldn't have to worry about this. If my database just loads everything in memory once and I use a terabyte of memory or terabyte of RAM to do it, great. Just let me just use that, and all the other free CPU use it for something else. For me to be able to now choose between all the different instance types. Okay, you have your CPU optimized instances, you have your memory optimized instances, you have your general purpose instances, then you've got your IO optimized instances, which is ones like these. I think I would be paralyzed trying to figure out which one is right. And then, of course, you have your burstable instances with the T family. So, yeah, I think I would be completely paralyzed trying to figure out which one to pick for a production workload.
Well, I guess it's probably moving in the direction the way computers have moved, where unless you're a gamer, you probably aren't going to be too worried about the specs of your personal computer. I bought a new monitor recently on Prime Day, and I felt that paralysis just trying to sort through the specs, and do I need 144 hertz of refresh, and all the different trade-offs that you make, and it's just, you're right, you shouldn't need to worry unless you have extremely specific requirements, and otherwise the system should just deliver you the performance you want, or stay under your budget. And you really need to just specify constraints rather than looking at it from, well, like we looked at the other one with, we had to deal with the number of nodes in the cluster, right? You shouldn't have to deal with this. And maybe we're at the tail end of most people worrying about the particular instance type that they're using. And maybe in 5 years, we won't be having this conversation. We'll just say everything is serverless or auto scaling, except for very specific use cases.
Yeah. I think my hypothesis is slightly different in that Aurora is actually turning into a setup where you can bring in your legacy on-premise databases and just host them in the cloud as efficiently as possible. And that's the use case. But if somebody was creating a very specific performance-oriented use case, I think the way to go for a cloud-native architecture is to split out your data stores based on your use case. So if you need a transaction data store, use something like DynamoDB. If you need analytics, you need OLAP, use something like Redshift or S3, depending on what your latency requirements are. If you need full text search, use something like Elasticsearch or Kendra, depending on what your use case is. If you need a graph data store, use Neptune. So there are if you need caching, where you just need to pull out data right then and there, use something like Redis, or Elasticache in the case of
MemoryDB.
Or whatever the variant of Elasticache you want to pick out of the AWS services. I think that's the way to go about it when it comes to building a truly cloud native, specialized, high performance data store.
Well, even in the name Redshift, right? The idea was you're shifting out of Big Red.
Yes. That is more for the OLAP kind of queries. Right? I mean, yes, you are. I do think that that's the way to go. Aurora seems like, initially I thought, hey, Aurora is an awesome cloud native database, and that would become the foundation for the future. But I think I'm changing my views on that. Aurora is a great midway point, moving your old traditional relational data stores to the cloud, but you're still carrying all those stored procs. You're still carrying all that data. You're still carrying the old relational mindset of denormalized data, of normalized data that you put, and then you do these tons of joins and stuff like that. That old mindset or old way of thinking about your data and how it gets accessed, where you want one I don't know, generalized monkey to do all your tasks. That is basically what a relational data store was, and I think continues to be for those old workloads. If I were building a cloud native solution, I'd think very differently about it today. I'd separate out the stores based on what they need to do.
Yeah, I totally agree, right? You shouldn't be reaching for Postgres necessarily. You start with Dynamo if you were doing something from scratch. Start with Dynamo or Neptune, or something depending on your use case. But
exactly.
But we're not living in a vacuum. There's a huge amount of SQL databases out there that exist, and they need to be brought in over time and in a way that just doesn't break everything all at once.
Yep. Exactly.
All right. Well, it looks like we've hit our, speaking of constraints, we've hit our time constraint for the day. Any other messages for the audience? Or I think we've got a few different things we're going to try for next week. I'm pretty excited about those.
Right. No, I think I like this new framework. Audience, let us know if you like this new rubber stamp that we put on all of these announcements, on whether they are simplifying stuff or complexifying your life. These are our opinions, but we'd love for you to opine on it.
Cool. All right. Well, thanks, everyone. Thanks, Rahul. It was really a pleasure, and we'll see you next week. And hopefully we'll see you next month in Anaheim. Maybe we'll be jamming on some ukuleles together.
Please don't make me play the ukulele on stage. So please show up.
All right. Bye, everybody.
Awesome. Thanks, everyone. Bye-bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.